Hello everyone, welcome back. Today I'm going to be talking about delta and Y three-phase power configurations. And this is important to understand the two types of configurations that we often see, and it's something that took me a little bit of time to wrap my head around. And there's pros and cons to using either configuration, and there's a few variations here in North America that you can see, in particular the center tapped delta configuration. So without any further ado, I'd like to get into this video, and this is a brief overview, but it's only meant to really teach you the foundation of what you need to know for each of these. I won't be going too far into the derivations. So the first thing to check out here would be this Wikipedia page to give you an understanding. So here we see the Y configuration with the neutral, and here's the delta configuration. Now a little bit on the pros and cons to each. Again, here, this is a delta because it looks like a delta, and here's a Y because this looks like a Y. So a little reasoning on why you might want to use a 4-wire Y. There are symmetrical phases, there's symmetrical voltage between the phases and the neutrals. So here, and I've stolen some images off the internet to help with my explanation and speed things up because we're all busy and we have lives to live. So here, we have symmetrical voltages between the phases and the neutral. Here I can see from line 1 to neutral, 120 volts. Likewise, line 2, line 3, 120 volts. Now notice that these are all, each line is 120 degrees out of phase, so you're going to get 208 volts line to line voltage. And right now it's going to seem like a magic number, but that's due to the factor 1.743. We don't need to concern ourselves with that right now. Like I said, this is just a brief overview. So the Y will be used when a mixture of single phase and three phase will be served. And you can feed one phase. Whoa, where are we going here, pal? Alright, you can some other things to keep in mind is that you can feed one phase and then the neutral to a residential customer, so it makes it very practical. And we don't want imbalances because the neutral wire here, oops, not that neutral wire, this neutral wire, that can carry the unbalanced current. So design considerations have to really take those imbalances into considerations and make sure that we're seeing a balanced load from the place of supply by design. So that's some of the challenges that's incorporated. Now there are 4 different combinations between Y and delta, meaning going from Y to delta. I'll just list them out now. So we have YY, and the way to remember it is whenever you're going to a Y, you're going to a high voltage. That's the most common application in which you will see them. So YY is small current, high voltage. We have delta delta, which delta would be high current, low voltage. Delta Y, which would be high current to high voltage. So you'll see that at a generator side. For instance, at a hydroelectric plant, the turbines are generating a large amount of current, and that's going to be converted into a high voltage so that you can send it over long distances. Y delta, this will typically be seen at the end of a distribution line. going to the service to the customer or stepping down at a substation to a distribution line, because we're going from high voltage to a lower voltage. And this is the example that we'll see at the end of this video. So this is the configuration that we're used to seeing in textbooks, but there's another configuration that I would like to show you. We explained a little bit about the delta, or the Y configuration. Now let's talk a little bit about the delta. Delta, we can see that each of the lines connected, lines 1, 2, and 3, 480 volts between the line to line voltage. So it's symmetrical. So anytime that you will see a delta transformer, you'll typically see 480 volts. And then here, this one, if it has this Y has a neutral attached to it, you'll see 208 Y slash 120 volt. And this Y gives you an indication that it is a Wye transformer. Note that there's also a delta high leg configuration. This is commonly seen in North America. It's becoming more rare, but from what I've read, but you can still see it, so it's important to understand that you have to identify what's known as the high leg conductor. And by convention, this will typically be phase A. But here we see it's line 2 here. This is multimeter between line 2 and the neutral. So why is this 208? Why is that the high leg? Well, because we have one full winding and a half. 1.5 windings, that will be your high leg. We can see from line 3 to neutral, we just have a half, as well as from 1 to neutral, we also have a half. So this is 120, 120, and then the 1.5 yields 208. Something to consider. Now this is an orientation that is a little bit more real world and easier to wrap your head around. So this is the exact same thing as the first photograph here. But you'll notice it looks a little bit different. And we can see the 3 lines coming in on the delta individually, right? They're each separated by 1 winding, so it's symmetrical. And then here, to identify a Y bus, we want to notice that they all have a common node going to neutral. And when you look at a Wye transformer, that neutral comes out of the middle here. So this is the common node. But this is a little bit more abstract to my mind than something like this, which is how you would actually see it in the real world being wired. And I have a little surprise for you guys in a moment. Really quick, this is why we use the center tap. Delta. Center tap delta allows you on the distribution and the customer side of things to easily convert. You can draw 240 3-wire 3-phase, or you can choose using the 2 non-high wires and the neutral. You can have 120/240 3-wire. And the advantage to that is you are getting 120. You're getting 120 by going from one of the lines to neutral. Or for higher demand loads, you also have a 240 available if you go from here to here, right? Because in between C and B, I can look up here and see 120, 120. Well, that'd be 240. So there is some purpose for the center tap, and I just wanted to briefly bring your attention to that. Now, let's see a real-world application of a Wye delta. So as you remember, we're going from the high side, or the primary, to the secondary, as they're called in a transformer. So how would we wire this if we're going from a Wye to a delta? Well, let's use the more intuitive understanding here to think about this a little bit first. So I have my A, B, and C phase coming in for the Wye. And each one of those, one side of the coils, is going to connect A, B, and C. So let's do that now. Great. Now, the other side of this bushing is going to connect. The other bushing is going to connect to the neutral. But on the high side, where that neutral is actually just going to be floated. So I'll draw a dashed line. Right? And this is our neutral. So now down here, these are the coils of our delta.